Good evening, afternoon, or morning, depending where you are. Welcome to day 9 of Newcomers for Nuclear Summer School. Today, we delve into the legal and environmental dimensions of nuclear science, from the Comprehensive Nuclear Test Ban Treaty to the role of nuclear energy in addressing climate change. We are reminded that nuclear science is not just about technology, it's about global responsibility and sustainability. So these conversations are vital as we shape a nuclear future that it is peaceful, lawful, and climate resilient. So let's engage with open minds and bold ideas, and thank you for being part of this dialogue today. So for today's agenda, we have three great speakers: Lisa Field from Canadian Nuclear Safety Commission, Martin Kalinowski from Peace Science Collaboration, and Christina Talaco, Glow Strategies CEO entrepreneur. So, and two great moderators, Sana Rufin from Benin and Dr. Mudu Nian from Senegal. So for today, we would like to invite Mr. Martin Kalinowski, who's a nuclear science freelancer and former staff member of Provisional Technical Secretariat of the Comprehensive Nuclear Test Ban Treaty Organization, CTBTO, based in Vienna. Please, Martin, the floor is yours. Thank you.
Yeah, thank you very much for your kind introduction and welcome. Good evening, good morning, good day, wherever you are. I would like to stress the importance of the young generation to educate yourself, grow, and be ready to take a lead. And you're in the nuclear domain, you're really stepping into this domain in a very exciting time, because it's now growing and expanding it again, and not just quantitatively, also qualitatively. There are so many new concepts being developed. This SMR reactors, the thorium reactor, floating reactors, and so on. And don't forget about fusion energy. For many years, people thought it's 50 years in the future that the fusion power reactor would be operational, but now there are about a dozen startups that are in competition to have the first fusion power reactor, nuclear fusion power reactor online, providing power to the grid. And one company wants to do this even in 3 years' time from now, and others are less ambitious and say something like in 7 or 8 years. But this is absolutely exciting. Also, artificial intelligence is driving the request for stable, reliable power generation. And you may have heard that Microsoft and other companies have made contracts for their data centers to be served with a nuclear power station that they kind of buy. So it's absolutely exciting time. It's the right time to join this field. So I want to stress that there are also non-power applications in medicine and agriculture, in climate change research for using isotopes. Really, there's so much to be done, and that's great for you to start. So some hints what you may consider. You already took a very good step in joining the summer school. It's an excellent summer school. Maybe you are studying already at university, nuclear engineering or related field. What I really recommend is that you get hands-on experience, real practical experience. And of course, internships are always a very good opportunity to gain experience. Look out for international, abroad opportunities. You may have heard that the IAEA has just announced the Marie Skłodowska's Curie Fellowship Program with the deadline for application end of October. This is a scholarship for internships for more women in nuclear. And don't confuse it with the same name of a fellowship, the Marie Skłodowska Curie postdoctoral fellowship by the EU. So that's also an opportunity that I want to highlight. Another opportunity is mentoring or supervising. So I am, for example, collaborating with emerging nuclear experts in Burkina Faso, Iran, Senegal, Tanzania, just by cooperating on a common project that I'm kind of guiding, but someone is learning from this. And then we next week we have a common presentation at the Science and Technology Conference of the CTBT. So this is just one way of liaising with experienced experts and join forces and become tandems, kind of. Also social media, please use all your social media channels to build a community, build your network. So that's all I wanted to say, to encourage you to step into this fantastic science and technology domain. I will talk later today, and I will talk about CTBT not only as an arms control treaty, but also it has a lot of relationship to the nuclear science and technology domain. So wait to see my presentation. Thank you. This is hand over back to the moderator.
Thank you so much, Martin, for those inspiring words. Definitely, you already give an entire roadmap of a bunch of opportunities that the young generation can turn over in their career. So we really appreciate your inspiring message. So
thank you
please,
for
I
the
would like
opportunity.
to thank you. Thanks to you. Thank you very much. So I would like to hand over to my dear colleague, Lancina. He can help us to introduce the moderators and panelists, sorry, for today's session. Yes, please, Lancina, over to you.
Okay, thank you so much. Good evening, good afternoon, good morning, wherever you are. I'm Lancina from Burkina Faso. I work with Laurentia to set up this first edition of newcomer country in nuclear. The initiative is NewComers4Nuclear. The first edition, we will thank the speaker and the moderator globally. And today's session, we have like moderator Sina Rufin from Benin, Dr. Moudou Niang from Senegal. We have speaker Lisa Thiel from Canada, Martin from Canada, and Christina Taglu from Australia. Thank you so much to be with us to set up the first edition and to bring in the high level we expect. I'm going to present to you Sina Rufin Dusu from Benin. Sina Rufin Dusu is a medical physicist and senior radiographer from Benin. She's acting by the Ministry of Health and Benin to the radiotherapy department of the International Hospital of Calavi. She completed her master's degree in medical physics in 2024 after previously earning a master in medical imaging and radiography in 2011. She has further strengthened the expertise for specialized international training program organized by the AA in radio protection, oncological imaging, and nuclear safety and security. She has extensive professional experience as a medical imaging technologist and radiation protection officer in several hospitals in Benin. Beyond her critical work, she is an active member of Women in Nuclear. She is also contribute on a volunteer basis as the Benin representative of PINT of Foundation, advocating of cancer awareness and patient support. In addition, she leads the committee establishing Women in Nuclear Benin, promoting women leadership and engagement in the nuclear science and healthcare. Now, I'm going to present Moudou Niang. Moudou Niang has a PhD in atomic and nuclear physics at the Institute of Applied Nuclear Technology, NTNA, University of Dakar in Senegal. He is part-time lecturer in the Department of Physics at the University of Dakar. Additionally, he works as a nuclear safety and security inspector at Senegalese excuse me, I'm so sorry, at the Senegalese Authority for Radiation Protection, Nuclear Safety and Security. Okay, I feel to present the two moderators. Thank you so much to be with us and to highlight this summer school. Florasha, the floor is yours.
Thank you so much, Lancina. So I'd like to hand over to Senna Rupin for her moderation time. Please, Senna, if you can help us to introduce Lisa, that would be great. Thank you.
Thank you, Florencia. Good morning or good afternoon, everyone, depending on where you are, and welcome to session 9 of our summer school. Our first presentation today is on the legal framework for nuclear safety. I'm delighted to introduce our distinguished speaker, Mrs. Lisa Tuel. So, Mrs. Lisa Tuel is the Vice President of Legal and Commission Affairs and Senior General Counsel at Canada's nuclear regulatory body, the Canadian Nuclear Safety Commission. She leads both the in-house legal services and the Commission registry, which manages all of the Commission's public proceedings. Mrs. Lisa has extensive expertise in nuclear regulatory law, both at the national and international levels. She is on the board of management of the International Nuclear Law Association and serves on the board of directors of the Canadian Nuclear Law Organization. She has been on the faculty of the IAA Nuclear Law Institute since its inception in 2011. And she is a lecturer and supervisor board member of the International School of Nuclear Law, a graduate diploma program offered at the University of Montpellier in France. She represents Canada as a member of the Nuclear Law Committee of the OECD Nuclear Energy Agency and shares its working party on the legal aspects of nuclear safety. Lisa has been privileged to serve as a lecturer and mentor in the World Nuclear University Summer Institute Leadership Program. Lisa was called to Ontario Bar after a clerkship of the Federal Court of Canada, and she is a member in good standing of the Law Society of Ontario. She holds undergraduate and law degrees from Queen's University in Kingston, Ontario. Mrs. Lisa Tuel, the floor is yours. Thank you.
Thank you so much for that introduction and these kind words. I'm very happy to be here. And I sound check. Can everyone hear me okay?
Yeah. It's
Yes?
okay, yes.
Yes, wonderful. Oh, good. And my slides are here. Perfect. So I have a short period of time in which I'm going to run through the international legal framework respecting nuclear safety. So it's not security or safeguards, it's nuclear safety. And next slide, please, Noor. We'll talk about generally what nuclear safety is, and I'll talk about the international instruments, both binding legal instruments and non-binding ones, and then a few words at the end about considerations for implementing this international framework into national law. Next slide, please. So if we talk about nuclear safety, it's concerned with protecting people and the environment from harmful effects of ionizing radiation. So that includes things like radiation protection, environmental protection, safety culture, management of waste, transport, emergency preparedness. These are all aspects of nuclear safety. The international legal framework addresses these elements in both binding and non-binding instruments. And then to bring those international requirements to a national level, national nuclear legislation generally implements these principles at the national level. Next slide, please. So the instruments themselves, I'm going to talk about 7, which basically cover off most of the instruments. The first 4 are binding instruments. The other 3 are non-legally binding. It does not make them less important. and we'll just run through them quickly. You'll have the slides because we won't have a lot of time here today, but you'll have the slides, and if there are questions that we don't get to afterwards, then we'll try to answer them perhaps by email after that. So next slide, please. We'll start with the big one, the Convention on Nuclear Safety. So the Convention on Nuclear Safety is a binding treaty. It has 98 contracting parties, and it applies to the safety of nuclear installations. And that means land-based civil nuclear power plants. It doesn't apply to research reactors or to any reactors that are for military purposes. It's an incentive convention, which means that the contracting parties implement the obligations in their national law. They report on how they've implemented those obligations, and they attend a review meeting once every 3 years. Next slide, please. 3 objectives of the convention: general nuclear safety objective, to achieve a high level of nuclear safety worldwide. Radiation protection objective, to establish effective defenses against hazards, and a technical safety objective to prevent accidents and mitigate the consequences in the event of an accident. Next slide, please. So contracting parties, when they sign on as parties to the convention, they agree to implement a national framework of safety requirements, which includes licensing, a system for compliance verification and enforcement of requirements at the national level, and a regulatory body is adequately protected from promotion. It's independent, and it has the authority, the competence, and the resources to do its job. And the third aspect of the legislative framework is responsibility of the license holder. They have prime responsibility for safety. Next slide, please. I'm not going through the general safety considerations. Articles 10 through 16 set out what national legislation has to provide for with respect to contracting parties. Next slide, please. Specifically with respect to nuclear installations, the safety requirements of the convention address siting, design and construction, and operation. So those are the 3 stages that have a whole lot of requirements that contracting parties have to take adequate measures to implement into their national laws. Next slide, please. Under the convention, contracting parties submit a national report on how they've implemented the obligations. Those reports are reviewed by other contracting parties. And then once every 3 years, there's a review meeting that takes place at the International Atomic Energy Agency in Vienna, where there are country group discussions, and then basically a country review report, which is concluded with respect to each contracting party. Next slide, please. Post-Fukushima, after that big accident, the contracting parties to the Convention on Nuclear Safety adopted in 2015 this Vienna Declaration on Nuclear Safety with respect to the principles to guide the implementation of that third objective, to prevent accidents with radiological consequences and mitigate those consequences if they do occur. And contracting parties decided, though the declaration is not part of the convention itself, contracting parties decided that future national reports under the convention would include how contracting parties had incorporated the Vienna Declaration. So that's a quick run through of the CNS, likely the most important nuclear safety international binding instrument. Next slide, please. We'll move on to its sister convention called the Joint Convention. And whereas the Convention on Nuclear Safety deals with siting, construction, and operation of nuclear installations, the Joint Convention deals with the safety of radioactive waste management and the safety of spent fuel management. It's joint because it addresses both spent fuel and other radioactive waste. And you'll see there it applies to spent fuel from civilian reactors, radioactive waste from civilian applications, uranium mining and milling waste, so fuel cycle wastes, and discharges from regulated activities. It does not apply to spent fuel and radioactive waste from military or defense programs in particular. Next slide, please. The Joint Convention objectives look a lot like the objectives of the Convention on Nuclear Safety, but specifically in the context of radioactive waste management and the safety of spent fuel. So basically the same three big objectives. Next slide, please. The obligations on contracting parties under the Joint Convention also resemble a lot the obligations with respect that the structure is very similar to the Convention on Nuclear Safety, with general safety considerations, independent regulatory body, legislative and regulatory framework, safety requirements that address both existing facilities, decommissioning procedures, facilities for the management of radioactive waste, and for the management of spent fuel as well. Next slide, please. There are specific provisions with respect to transboundary movement of radioactive waste, which involves prior notification and consents. And specific Article 28 deals with disused sealed sources. And there's a little bit of overlap there with another of the instruments that I will talk about in just a minute when I will have some time. Next slide, please. Peer review. So under both of those conventions, they are compliance verification is done in the review meetings where contracting parties review the national reports of each other, and they get together and learn from each other. And that's a place for international cooperation, learning about good practices, identification of specific challenges, and a general increase in nuclear safety for installations and for management of radio waste in those contexts. Next slide, please. Convention on early notification of a nuclear accident. This came into force just after the Chernobyl accident. It deals with a notification system for nuclear accidents with potential transboundary effect. This was something that hadn't been in place before Chernobyl, and this was meant to address that, to deal with the international community and how it deals with accidents. Because we've heard an accident anywhere is an accident everywhere, and transboundary effects we know can happen. Next slide, please. That convention sets out state party obligations for notification, response, and the conduit of that notification can be the International Atomic Energy Agency, which has a specific role under the Convention on Early Notification of an Accident as well. Next slide, please. The other convention that that came close after the Chernobyl accident, Convention on Assistance in the case of a nuclear accident or radiological emergency. Also a binding treaty, came into force in 1987. It addresses the requests for and provision of assistance from the international community. It also has governance on how that assistance may be sought, may be requested, may be provided. Next slide, please. I'm going very quickly in the interest of time. Oh, sorry, next slide again. I've moved on to so that covers all the binding international agreements. Now we get to the transport regulations. It's a safety standard of the IAEA. It's not a treaty. However, it does apply to all radioactive material, worldwide transport, all modes, land, water, air. And basically at a global level, it has been incorporated into many legally binding instruments and arguably has become customary international law. Next slide, please. Code of conduct on the safety of research reactors. It's not a treaty. It provides best practice guidance as a basis for national regulating in order to achieve and maintain a high level of nuclear safety with respect to the operation of research reactors, which are used mainly for generation and utilization of neutron flux and ionizing radiation for research and other purposes. And the code of conduct deals with the role of the state, the regulatory body, and the operating organization. Next slide, please. Sets out what should happen at the state level, what should happen at the regulatory body level, and there is also separate guidance provided for the regulatory body and for the operators of a research reactor with respect to those issues that are identified at the bottom of this slide. Next slide, please. Code of conduct on the safety and security of radioactive sources. This is important to everyone because it's a rare country that doesn't have a need for radioactive sources. So this code of conduct is not a treaty, but states are invited to make a political commitment to it. Its scope is on high activity radioactive sources. It is supplemented by two important guidance documents, one on import and export and one on management of disused sources. So it's here we see a little bit of overlap with the joint convention where it deals with disused sources. Next slide, please. This code of conduct assists states to establish their policies, laws, and regulations to ensure that sources are safe and secure. So not just nuclear safety, but nuclear security as well throughout their life cycle. And so those bullet points on the slide identify what states should have in place to ensure these things, to allow for the trade and transport and use of radioactive sources, which is why there's specific import and export guidance as well. Next slide, please, which is my last slide. I know I'm coming to the end. When implementing this international framework into a national nuclear law, some key things to keep in mind would be whether you've chosen to be bound by it. So appreciate your state position with respect to it. There are related standards and guidance by the IAEA that help to elaborate on the fundamentals here and provide very useful specificity on the greater guidance that's provided. The scope, application, and definitions in these instruments are very important to pay attention to, especially if they're binding international law. And some issues are cross-cutting in several instruments. Requirements for a regulatory body to be independent, requirements for a licensing scheme and for regulatory oversight of compliance with that licensing scheme. And just to conclude, my whirlwind overview has been about nuclear safety instruments. if your scheme is meant to address security, safeguards, and nuclear liability, then you'll want to pay attention to those instruments as well. And with that, I thank you for your attention and hope we can have some Q&A.
Thank you. Thank you, Mrs. Lisa, for your insight presentation. So we will now open the floor for question and answer. Please feel free to raise your hand or write in the chat. Mrs. Lisa, we have a question with you. Eva is asking, how many member states are signatory of these conventions? And what is the difference between a treaty and convention?
Okay, so on the first question, the numbers do change, but I think on all the binding conventions, I've indicated on the opening slide how many contracting parties there were to each of them. So, for example, for the CNS, there are 98 contracting parties. For the Joint Convention, 91 contracting parties. And so that information should be on the slides. And the difference between a treaty and a convention, there is none. It's just the name. Treaty, convention, international agreement. There is a Vienna Convention on the International Law of Treaties, but convention is synonymous with that. So they are the same thing. So thanks for that question.
Okay, thank you, Mrs. Lisa. So we don't have another question.
Well, I know I've taken a little more than my time than I was supposed to, so I apologize.
Don't worry. So I think that it's all about the question.
If any, I know that we had in our intro some discussion about fusion, about SMRs, and so some of the questions that the international community is looking at is what's do these safety conventions apply? And so those are some of the things we're working on. And it's important to review the definitions. So nuclear installation is defined in the Convention on Nuclear Safety. And so, and it is land-based civilian nuclear reactors. So an SMR that was land-based would absolutely fall under that. Floating SMR, whether it's land-based or not, like is it tethered to land or not? So these are some of the questions that we're looking at now.
Thank you, Mrs. Lisa.
Lisa, can we have your permission to share your email on the chat to the participants?
Absolutely. And if someone wants to ask a general follow-up question after they've reviewed the slides, yeah, great. Yes. So you have my email there, Noor. Feel free to put that in the chat as well. I'm happy to communicate with folks.
Thank you so much, Lisa. Over to you, Senna.
So, thank you, Mrs. Lisa. We thank you for this incitement and thank all participants for your question and engagement. We will now move on the next presentation of this session. Florencia, it's okay.
Yes, thank you very much, Senna. And we follow up with Dr. Mudu. Please, over to you. Martin, the floor is yours, and we say goodbye to Lisa, and thank you for staying with us, Lisa, for your great participation.
Okay, thank you very much. Good evening, good afternoon, it depends where you are. Today we have Martin as speaker. I'm very happy to moderate the present of Martin. Martin's Carlson is a nuclear science freelancer and former staff member of the Provisional Technical Secretary of the Comprehensive Nuclear Test Ban Treaty Organization, CTPTO. Amongst others, he served for 7 years has head scientific method unit. From 2006 to 2012, he was professor and director of Saar Friedman Center for Science and Peace Research at the University of Hamburg, Germany. In 2005, he was assistant professor for technology and international. Martins, you have the floor, and thank you very much for your availability.
Thank you very much, Madhu. So I'm going to present on CTBT matters, Comprehensive Nuclear Test Ban Treaty. I didn't put my email address here, but I have my own website under construction, and the main thing that you can find there is a contact form, peacescience.net. So that's always a way to get in contact with me. I start my laser pointer. I hope you can see this red dot moving. And I have a presentation in 4 sections. First, I introduce CTBT-O, then the verification system, then DPRK tests, and then radionuclide monitoring. History, you see the bar chart here of all the nuclear tests over the time. And since the Comprehensive Nuclear Test Ban Treaty was open for signature, almost no more tests were conducted. And since the Partial Test Ban Treaty went into force 1963, almost no more above ground tests took place. So bars go down underground. The Comprehensive Nuclear Test Ban Treaty was negotiated in Geneva and open for signature in 1996. And 1 year later, the Provisional Technical Secretariat started operating in Vienna. And here we have in Vienna the Preparatory Commission, and it meets every 2nd year, 2 times a year. And the executive secretary is currently Robert Floyd from Australia. And once the treaty is in force, it will become the Technical Secretariat, what is currently called the Provisional Technical Secretariat. And I joined it a year after it was established in 1998. The CTBT will enter into force as soon as all 44 states in Annex 2 have ratified, so signed and ratified. There are 3 countries that have neither signed nor ratified. There is 1 country that signed but de-ratified the treaty, and 5 countries that signed but did not ratify yet. Okay, now verification system. The verification system consists of 4 elements. First is confidence building measures. That's something you do before you explode, a chemical explosion in a mine or something like this. You inform about that. Then the second is the international monitoring system that could spot any sensitive signals. Once an interesting signal, suspicious signal is identified, there is a phase of consultation and clarification among states. And if there is no agreement on what happened, there may be on-site inspections, but only after entry into force. Most of the time, I will talk about the international monitoring system. Just 1 slide on the on-site inspection. There has been 1 experiment, which is called an integrated field experiment, 2014 in Jordan. And the next one will be next year in Namibia. And so it's a decade that passed until this next big effort to demonstrate the capability, the readiness of all technologies and procedures to conduct on-site inspection. Okay, now the international monitoring system. It consists of 337 facilities. 16 of these are laboratories, radionuclide laboratories, and the others are seismic. I show you here more detail. 170 seismic stations, 60 infrasound stations, 11 hydroacoustic systems, and 80 radionuclide stations, which have basically particle bound filter samples, but also half of them, 40 of these stations, will have a noble gas system for radioxenon. I will talk a lot about radioxenon here. The seismic people hydroacoustic infrasound, they record all the tectonic events, so the earthquakes. And what you can see here are the tectonic boundaries marked clearly with all the red dots where the earthquakes happen. So most of the time we notice earthquakes, but sometimes there are explosions, and the seismologists can distinguish between earthquake and explosion, but they cannot say whether an explosion was a nuclear or a chemical explosion. So we need radionuclides to give an indication. And the radionuclide system for a typical year has only maybe 10, 12 samples that are of increased interest, which means it contains at least 2 CTBT relevant isotopes, and there are 80 different isotopes that are CTBT relevant. And here the pie chart shows you the frequency of isotopes observed in that year. Sodium-24 is a natural one, but it could also indicate in nuclear tests. So the most frequent anthropogenic isotope is cesium-137, followed by iodine-131, cobalt-60, and so on. So that's what we normally see. It's typical background in the atmosphere from normal operational releases from nuclear facilities. But for radioxenon, the map looks completely different. Every station that monitors radioxenon picks up a lot of radioxenon from normal operational releases. It's an extremely sensitive network that can detect quantities that are really orders 10, about 12 to 16 orders of magnitude diluted compared to what was released at the release point. So it's an extreme sensitive detection system. And what are we normally seeing are the releases from nuclear installations. And here you see the map of all the known nuclear installations. Of course, there are more in certain regions like Europe and North America, but we are mostly interested in what is called MIP. It's a medical isotope production facility, because one big medical isotope production facility releases into the atmosphere more radioxenon than all nuclear power plants together. And nuclear research reactors, one might think they are a very tiny source, but some of them are strong emitters and have interesting features like not fission xenon, but activation. So xenon from activation is emitted. So interesting things. Spallation neutron sources, yeah, we consider them, but we found that they are of minor relevance. Now let's talk about the DPRK tests. How many were there? 6 of them. So it started 2006, then 2009, and then a sequence between 2013 and 2017. The magnitude is measured with seismic sensors, and you have an indicator how a seismogram looks, a seismometer looks. And here you see the amplitude of the first nuclear test, 2006, and the amplitude of the last test was the largest. Magnitude is measured in a logarithmic scale. Therefore, if you go from 5.1 to 6.1, it means a factor of 10. Larger amplitude, and this is the amplitude measured here from 0 to maximum. That's the amplitude. The location precision is fantastic. Look at these so-called error ellipses. So they indicate the 95% probability region where the test is located, with the center of the ellipsoid that indicates where we think the test was. Here zoomed in, and now look at the scale. This is just 100 kilometers. And once there is a single test and then a second one, we can use cross-correlation methods of the seismic signals to measure the distance between the two to 100-meter accuracy. It's unbelievable, fantastic accuracy of seismic signals. But it's important, because if on-site inspection is scheduled to take place, then the maximum size that is allowed to be inspected is 1,000 square kilometer. But we are now, with this sensitivity, we're going for DPRK tests, we go down to 100 square kilometers. So it's fantastic accuracy. Radionuclide monitoring is not so successful. I list here all the 6 tests of DPRK, and I give you some parameters like which station saw something. And I don't go into detail here. You can look later at the slides. But in 2 cases, the signals, the radioxenon signals that came out of underground nuclear tests into the atmosphere traveled thousands of kilometers to the next radionuclide system that measured it. In 2 cases, we detected clearly and were able to associate the observations with the test. There is one other case where scientists 2 years later demonstrated that, yeah, they can have a location, field of location where they think the test, the observations came from, and the DPRK test site is within this region. So they think they have high confidence that also observations in 3 different systems of the IMS system saw releases from that test. Okay, I want to mention the role of national authorities, because the Technical Secretariat in Vienna and its International Data Center, IDC stands for International Data Center, provides all the data and analysis products to the states without prejudice to the final judgment of the nature of the event, because that shall be the responsibility of states. So this is an absolute democratic treaty. It's not like safeguards at the IAEA, where nobody knows what they measured, they just report the results. But here it's different. All the measurements are made available, all the analysis by the International Data Center are made available, and then the states have the responsibility. But how do they do it? So they may establish a national data center, and there are now 149, almost 150 states have already established a national data center, and 20% of them are located at nuclear establishments like the National Atomic Energy Authority. So here I give you a hint to the connection to the nuclear field, nuclear expertise, nuclear technology field. So many NDCs are located at nuclear establishments. And NDCs can do much more than what the IDC, the CTBTO can do. They can use national data, they can use other sensor data like from satellite, the differential SRR data from radar satellites. And this can help to measure subsidences of the surface by a few centimeters from remote, from the outer space. And this will help to validate the location of the seismic event location. And it's fantastic what can be done. Now, radiant light monitoring, a few more information about that. The radiation releases from emergencies like the Fukushima disaster. Of course, we measure them across the globe. And here you see how the plume developed from Fukushima for 14 days. You will see an animation going for 14 days. It travels basically across the hemisphere. It doesn't transfer the equator likely easily, but within 14 days it travels once around the globe. And here you can see in yellow and red dots and orange dots where the radioactivity arrived on the day that is marked in the calendar. Here this is March 12th, and then time progressing, this has already stopped. But anyway, you can see how the plume traveled across the hemisphere. Immediately after Fukushima happened, the World Meteorological Organization, the IAEA, they wanted to have the data of the International Monitoring System, and it was shared under certain arrangements that are defined by the Interagency Committee on Radiological Protection, Radiological Nuclear Emergencies, IACRNE. There are 16 international organizations member of this interagency committee, and they have joint radiation emergency management plan rules according to which the CTBTO can share data with these other international organizations. Now, the almost last slide, I give you some examples of research being done with radionuclide data, with radionuclide data measured with the International Monitoring System. For example, climate change studies. I did this myself. I'm a co-author of this paper. Here you see the measurements over the latitude. So from northern stations to southern stations, you see that at the equator, there is no beryllium measured, but at other latitudes, you see maxima of beryllium-7, which is produced in the stratosphere from cosmic rays. And here on this axis, you see the years from, I think it was 2004 or 2001 to 2022. And you see that there is an increase in beryllium-7 from over this decade or 2 decades. Initially, the maximum was small, but nowadays the maximum is large. And what does this indicate? It indicates that more intrusion of air from the stratosphere reaches the troposphere. And why? It's because the tropopore's height changes. And this is a climate change caused effect. And so we can measure at the ground level with beryllium-7, we can measure an indicator for tropopore's height changes according to latitude. And this is fantastic because there are no sensors up there that can measure the tropopore's height. No satellites can measure this, no balloons can measure this, but with beryllium-7, we can have an indicator. Another example is prediction of monsoon onset. You can also use beryllium-7 for that. Another application of radionuclide data in the atmosphere measured by International Monitoring System stations is optimize certain parameterizations in atmospheric studies and atmospheric models. And in this case, it's the wet deposition scheme that was enhanced. Originally, the comparison between observations and simulations looked bad. And after enhancing the scheme, it now looks good. And this is important for emergency response because you want to know where the cloud is rained and washed out and deposited on the ground. I mentioned interhemispheric exchange is rare, but it does happen. So it can also be nicely studied here with the station at Papua New Guinea or this station at Fiji Island, which are beyond the equator, with Fukushima discharges spreading over the northern hemisphere, but also intruding into the southern hemisphere. Okay, good enough for science, but if you would like to get access to these radionuclide data of atmospheric radioactivity, you can get. As a scientist, your organization can apply for cost-free access to these data. They're not freely available in the internet. You have to apply, you have to get an account, but then you get what you want and do your research. Next week is the Science and Technology Conference. You can still register for this until the last day of the conference, actually. I really encourage you to look at the agenda and pick and watch online. If you cannot go to Vienna and to the Hofburg, you can watch online all the sessions. You can see Mudo presenting his e-poster and others. So look out for this. And my summary, the CTBT Preparatory Commission was established in Vienna, and it does operate a unique international monitoring system provisionally, but it's already delivering data. And for example, the DPRK tests were located very exactly, precisely. Even radionuclides from these underground tests were in 3 cases observed and associated with the tests. What we normally see are the operational releases of radionuclides from nuclear facilities. Very important to stress, national data centers have an important role in this treaty verification, and there are many nuclear installations that host national data centers. And of course, even if there is not if it's not hosted as a nuclear establishment, it requires, for example, as the seismic observatory, they need also the radionuclide expertise to complete all the technologies, the knowledge on all technologies. And then I highlight the additional benefit for civil and scientific applications of the data. So thank you very much for your attention. Now maybe there is still time for questions.
Thank you very much, Martin, for this interesting presentation and all information you are sharing. Now we try to answer some question in the chat. We have a question from Florencia. Florencia asks, how can the international multi-system balance its role in detecting nuclear tests with a growing application in civil and environmental monitoring, such as climate study and emergency response?
I tried to read the question myself. How can international monitoring balance its role in detecting nuclear tests with its growing application? Oh, well, that's easy. Civil and scientific applications are not done by the CTBTO. The CTBTO only provides data for this. So the CTBTO focuses solely on monitoring, and all the civil and scientific applications are done by others. So it's only providing access, that's all. Does this answer your question?
Now we have only one question from Franson. You are free to answer your question. Raise your hand if you have anything, if you have comment or question.
Dr. Mudo, maybe you would like to take a look in the Q&A answer session. We have one from Tamar and another one from Colette. You'll see it in the bottom of the Zoom platform. There is Q&A box.
We have a question. Okay, in the QA, you have isotope mapping QA. You have question in the QA, Martins. Isotope mapping so has concentration North America and South Asia. What period is this?
It's a whole year. Of course, I showed two different things, the Fukushima releases, but I think this question is referring to the maps where I showed numbers of observations at each of the station. And this was for 1 year. It just gives you an example of 1 year. It's one specific year. But it's a typical year. Every year looks similar.
Okay, we have another question from Tamar.
Yeah.
What are the main challenges in expanding and maintaining the radionuclide monitoring network?
Yeah, expanding. The network cannot be expanded because the stations were agreed during the negotiations, and they are listed in the annex, in the protocol, in the annex to the protocol of the treaty. So that list cannot be changed. Now, expanding means completing the network. And currently the network is 90% complete and 10% of stations are still to be built. And there are various reasons why they have not yet been built, technical reasons and political reasons. I should mention that there are a few stations reserved for India because India dropped out from the negotiations before they concluded. And so some stations are not assigned to a location, but you can find them in the alphabetic order in the location of India. So it's obvious that they were reserved for India. Another expansion topic is the noble gas systems. Currently 40 out of 80 radionuclide sites have a noble gas system. This was agreed also in the treaty because at that time, the states didn't really believe in noble gas monitoring. And they thought, well, if it doesn't work, why we should not invest stations at 80 sites. Let's first start with 40 stations, and if it works well, then at the time of entry into force, the Conference of States can decide to expand noble gas systems to all 80 sites. Then sustainment, well, that's very expensive because you have to constantly maintain the systems. You have, from time to time, you have to refurbish them. And we also modernize the systems. I still say we, because I identify myself so much with the organization. I'm no longer a staff member, but the organization invests, or the member states invest a lot of money to sustain the systems. They're currently discussing about best ways to do this and to finance the sustainment of the system.
Okay, thank you. We have another question from Adeline. The question is, what is the influence of not ratifying the convention and just signing?
Okay, those countries who have signed and not ratified,
Yeah.
technically it makes no difference. They have the same responsibilities, they take the same action, they pay their contribution, they build up their stations, they fully participate. Even Russia, Russia de-ratified to be on equal footing with the United States, that never ratified. But Russia did not change their commitment in any regard at the time and after they de-ratified. So not having ratified, it has no practical implication. It has only a political implication, because without ratification, the treaty cannot enter into force. Also, ratification means it's not entered into national law, but the example of Russia, China, India, the United States, not India, Israel, Egypt, it shows they are fully committed, and they are actually their most active states. So not having ratified doesn't do any harm, as long as there are still countries missing who have not even signed. But once India, Pakistan, and North Korea have signed, then all these missing states need to ratify to get the treaty into force.
Okay, thank you very much. We don't have another question. You are free to put your question. You raise your hand if you would like to add something. I think okay. No, go ahead. You can open your camera and unmute yourself.
Good evening. I think there is a question that is in the Q&A that is not answered from Tama. Her question was, what control or enforcement mechanisms exist for countries that do not comply with IEA regulations? For example, North Korea, which recently tested a nuclear weapon.
Yeah, the CTBT has no enforcement measures. The only action that can be taken is by member states to bring it to the Security Council, and then there are council resolutions. Again, there were several resolutions on the DPRK tests, and of course the resolution call for North Korea not to test again and to join the treaty. But you know what that means. It's just paper, it's just declaration. So there's no policing mechanism. And the treaty itself doesn't have any sanctions.
Thank you.
You're welcome. And else, if you have comment, or you are free to raise your hand or put your question in the chat. I think it's okay. Thank you very much, Martin, for your availability and the great information you are sharing.
Yeah, my pleasure.
Okay.
Thank you so much for your nice moderation. See you soon.
See you soon. See you soon. Yeah. Next week, inshallah. Flora, you have the floor.
Thank you so much, Martin, for your brilliant presentation, and we really thank you for all the contributions. We just shared the conference for next week at CTBTO, the website and the registration link. If someone is interested to participate, please utilize the resources. I think this will be a great event, and we wish you to Mudu and to you as well a great participation under this event next week.
Okay, thank you.
Thank you very much.
Thank you so much, Martin. We
Yeah.
keep in touch, and thank you for being part of this program. Thank you very
My
much.
pleasure. Thank you for inviting me. I'm happy. It's my pleasure.
Thank you so
Okay.
much. Now I'll hand over to Sena to introduce our latest speaker, Mrs. Cristina Talaco, that she can deliver us her presentation. Over to you, Sena. Thank you so much.
Thank you, Florencia. So we will continue today's session with a presentation on climate change, focus on climate for nuclear. This presentation will be led by Mrs. Cristina Talaco. I'm delighted to introduce her. So Cristina Talaco is a Brazilian-Australian entrepreneur, energy advocate, and environmental leader with a diverse career spanning business, law, and sustainability. She is the CEO of the Coalition of Conservation, where she drives bipartisan engagement on pragmatic climate and energy policies. Christina has been at the forefront of efforts to educate policymakers, industrial leaders, and the public on the role of nuclear energy in Australia, advocating for the removal of legislative barriers to its development as part of a balanced clean energy transition. She has worked extensively with government, international experts, and industrial stakeholders to advance sensible decarbonization strategies, emphasizing energy security, affordability, and environmental responsibility. She has participated in high-level delegation policy discussion and global forum to bring international nuclear expertise into the Australian energy debate. Beyond her policy work, Christina is a successful entrepreneur and the founder of Saldosh Fine Foods, a company specializing in allergen-sensitive foods, which has expanded to export its products to over 20 countries. Under her leadership, the company won the SW Export Award in 2016 and 2018. She has served on executive boards, including Beyond Zero Emission and Viridios Capital, contributing her expertise in sustainable finance and energy transition strategies. Christina held a Bachelor of Law from University of London and a graduate diploma in corporate law and governance from the University of Sydney. She has also completed an executive leadership program at the Harvard Kennedy School. Committed to philanthropy, she served on the board of the Charity of Mill. It makes a difference and is a benefactor on the art gallery of NSW. Mrs. Christina, sorry, the floor is yours.
Thank you, Sina, very much, and good afternoon, everyone. I'm very happy to be here and for the opportunity to speak to you today. So I come to this conversation from two perspectives, as Sina mentioned. One as the founder of Coalition of Conservation in Australia, an environmental charity. We work together to build a center-right pragmatic voice in the climate and energy debate. And it embraced nuclear alongside renewables, critical minerals, and all the clean technologies available. And we brought together parliamentarians, industry, communities to reframe the conversation away from ideology and towards solutions. And secondly, I come here as co-founder of Globe Strategies. It's a new global advisory focusing on energy, nuclear as well, and climate narratives, and bridging human expertise with technologies and AI to facilitate social license. The work that I've done has taken me across Europe, the US, the Middle East, and Latin America, where I see governments, I see investors, communities beginning to look at nuclear with fresh eyes, So I see that there's huge momentum. The countries that once dismissed nuclear are now debating it seriously, and countries that have never thought about it are including it in their plans. I also see the opportunity to position nuclear as tomorrow's climate tool. And that's why I'm here, because I believe civil nuclear power can be the bridge between our climate ambition and the climate reality that we're facing. So in slide 2, if we could move to the second slide, I'm talking a little bit about that climate reality check, because despite the record investment in renewables, global CO2 emissions hit 37.4 gigatons in 2023, the highest ever. So, and that's after 1.8 trillion spent on clean energy just last year. So we can see that there's a gap there, and electricity demand is set to double by 2050. That's being driven not only by population growth, as we know, but also by electrification of transport, by industry, by the huge rise of AI. And by 2030, AI and data centers are predicting that alone they would consume more electricity than India, so that's huge. So this is the reality check, in my view, that the math is not adding up. So without something more, net zero will remain out of reach, and our fight against climate change will fail miserably. So in slide 3, I talk about the climate and the nuclear, the missing link between climate and nuclear. Because what I mentioned, that we need something more, I believe that the something more is nuclear energy. Since the 1970s, nuclear energy has already prevented over 70 gigatons of CO2 in the atmosphere. That's more than all the wind and solar combined until 2015, according to the IPCC. So nuclear is the only technology today that provides 24/7 zero-carbon baseload power at scale. And crucially, it doesn't compete with renewables. It partners with them, despite the fact that lots of organizations and countries think that they're actually in competition. I believe that nuclear and renewables together offer that mix of flexibility and reliability that we need. But the problem is that nuclear still is, in many jurisdictions, including my own country, Australia, not recognized as clean energy, many times not backed by policy, and it's not being linked to climate change properly, which it should be, because as we see, it can reduce, and I'll show later in my slides on practical cases in different countries where it reduced immediately CO2 from the atmosphere once it started rolling. But one great development recently is the World Bank finally recognizing nuclear energy as part of the solution, which shows a big shift in how these global institutions view nuclear, not as a risk now, but as a real tool to cut emissions, and it will provide reliable, clean power, getting the backing of, or the signaling now to investors and governments that nuclear deserves a place in the table and in the fight against climate change. So I think that that could unlock the kind of support that we need to get more projects off the ground, especially in emerging countries. Now in slide 4, as I mentioned, I'll give you country examples and looking at real world evidence. In France, where I am at the moment, about 70% of its energy is generated by nuclear, as we know, and France's electricity emissions are 6 times lower than Germany after it phased out nuclear. In Sweden, the combination of nuclear and hydro that they have gave them 80% cut in the emissions since 1970s. So this link between nuclear and climate is not just theory, it's actually proven. It's proof that nuclear can cut emissions at scale, it can cut emissions quickly. In slide 5, next slide, I show that in Ontario, there's a graph there. You can see that after refurbishing their nuclear fleet, Ontario phased out coal by 2014. It's incredible. They eliminated 90% of CO2 emissions from the power generating sector. So smog days now in Ontario dropped from 53 in 2005 to 0 in 10 years by 2015. In the next slide, I'm showing some other examples of countries that are reducing emissions with nuclear. In the United States, for example, where nuclear provides 20% of power, but 50% of all clean electricity, it's avoiding 500 million tons of CO2 annually. So that's more than all the US passenger cars, which is huge. In Japan, now that reactors are coming back online, the nuclear has already avoided around 40 million tons of CO2 last year. And once they fully restore their nuclear activities, they could cut more emissions. In the UAE, in Baraka, which I visited last year, their nuclear plant already avoids 21 million tons of CO2 per year. That's equivalent to planting 350 million trees. And in the UK, nuclear already prevents 20 million tons annually. And I think that they wanted to have actually strengthen the backbone of the grid with nuclear. So in slide 4, the nuclear versus renewable, which I believe, it's really an unproductive debate, which happened recently in Australia, for example. The debate has not helped the nuclear cause. But yet we know that wind and solar are indeed variable. They're intermittent, they're land intensive, and I will make comparisons on my next slide between nuclear and renewables. But we still need that mix and a diverse system in every country as much as we can. And nuclear can offer that base load and steady supply together with the flexibility of renewables. Then on slide 8, we talk about land use, which, as I mentioned before, one of the things I'm passionate about nuclear is the low environmental impact that it has on land and on nature. So in terms of comparing land use for continuous gigawatt output, not just generation, nuclear requires only 1 square kilometer per gigawatt, whereas solar will require 200 times to 250 times more. And wind will require 500 times to 1,000 times more. And when we look at waste as well, over a lifetime, which is a controversial part of what nuclear, what we understand about nuclear, the volume of nuclear waste per person is roughly the size of a soda can. And it's been safely managed for many years, as we know. So nuclear is not just low carbon, but we also have to show that nuclear is low footprint on land, low footprint on nature and on waste. So in slide 9, the next slide, I've worked with many countries on narratives that work and narratives that don't work with nuclear. So how do we experts, scientists, how do students, how do the young people and the industry and advocates can assist in building this parallel between climate change and nuclear and building that bridge between nuclear and climate better? Narratives matter a lot. If you look at the polls globally and in different countries, they consistently show that when nuclear is framed as a climate solution, then the support increases dramatically. Some examples of that, in Australia 2 years ago, an Essential poll found that 55% people in Australia supported lifting the current ban on nuclear. And 70% of this 55% were young people under the age of 20. So this increase in support is directly related to young people worrying about climate change. The same in Finland, where public approval for nuclear is at a record at the moment at 68%, which is the highest in Europe. And that's thanks to transparency around, Olkiluoto-free and also the Onkalo repository, but it's also thanks to the support that they had from the young people and the Finnish Green Party that has helped nuclear gain more popularity there. And globally, Ipsos 2024 found that 72% of young people see climate change as their top concern. And increasingly, they're accepting nuclear as part of that solution, especially as the technology evolves. So this shows that linking nuclear to climate urgency resonates quite well and far more than all debates about kilowatt hours and any other argument that we've used in the past. In the next slide, just highlighting some narratives that I believe don't work. And unfortunately, they've been used widely many times. For example, language. The language surrounding nuclear is often quite technical. Acronyms are used and people don't feel they understand them well or they're not connecting with it. And the nuclear versus renewables framing that I mentioned are not positive narratives. ignoring safety when it's discussed or asked, and ignoring the waste, it will always backfire as well. So we need to be transparent. We need to talk about it with, data, with information, with expertise, and also maybe stop talking too much about the past things, because it makes us sound like a defensive, old-fashioned technology. Instead, we can talk, for example, about Germany's phase out as a warning by shutting nuclear. They're burning a lot more coal and increasing emissions by 20% since 2022. So these are positive ways of looking at nuclear. In the next slide, a quick overview of the Australian case. Australia is a paradox because it's the world's third largest uranium exporter. And yet it's the only G20 country where we have a legal ban on nuclear power, on civil nuclear power. But the attitudes over time have been changing quite significantly. And there's a big shift. Nowadays, the majority of people in Australia support lifting this ban on nuclear, especially amongst the younger generations. And that's because, again, the climate change issue and electricity price going up, and the limitations that people are finding with the variability of renewables, like barriers with social license that some renewable projects in Australia are suffering or facing from regional communities, from farmers, and from environmentalists. So if Australia embraced nuclear, we could unlock a 30 to 40 billion per year export industry in uranium conversion, enrichment, and advanced reactors. So while strengthening, of course, the energy security and climate credibility. But for that to happen, it's important that the young people start believing in nuclear and linking it to climate change, as it's been happening in the past couple of years. In the next slide, the Finland case, in contrast with Australia. Finland provides a completely different lessons with their Olkiluoto 3 online in 2023. Finland now gets about 40% of its electricity from nuclear. So they're slashing reliance on the Russian imports. They're cutting power sector emissions by 40% in 1 year. And Finland's Onkalo waste repository is the world's first licensed permanent solution for spent fuel. So what brought these changes in Finland? Transparency, public engagement with communities, and honesty about challenges that build trust. So this is a great model for social license done right. In the next slide, how to shift the dial. How do we communicate globally that nuclear can be an incredible tool for reducing emissions? Well, globally, as we know, nuclear momentum is growing. And countries like in China building a lot more nuclear new reactors, India expanding to 22 gigawatt by 2031. We see countries in Africa advancing nuclear programs, and in the Middle East, after the UAE, with Baraka, now Saudi Arabia and Egypt are moving forward, and even in Latin America. So emerging economies see nuclear not just as climate action, but they also see it as development, as jobs, sovereignty, security. So if nuclear reached just 25% of global electricity by 2050, then we could avoid 30 to 40 gigatons of CO2, which is equivalent to removing every car on Earth for an entire decade. In slide 14, global emissions. The potential to reduce them and how to shift the dial, as I mentioned. I think number one, we must reframe nuclear as a climate tool and not a political wedge. I've seen it happen in Australia that when it becomes part of a political argument, it loses it. So it has to be above that. It has to be a climate tool. And education is very important, and it has to be simple messages, avoiding jargon, avoiding too much technical language. Engagement with communities is extremely important as well, especially in countries where we have indigenous communities, regional communities, farmers. People must feel that they're part of this conversation and part of the solution. Otherwise, it's something that they're not going to be interested in. And most of all, empower the youth, because nuclear is about the future and not the past. So the evidence is showing us that companies and countries that link nuclear to climate ambition, they gain public trust, and the investment premiums are huge. So nuclear is not only an energy solution for them, but it's like a climate and economic multiplier. And it offers hope mainly for the young people and the new generations in terms of reducing emissions. And in my last slide, the call to action and my closing remarks is just to wrap up, to leave with you the message that the climate urgency has reframed the nuclear debate, for sure. People now see nuclear as a climate tool. It's not an old technology anymore. Extreme weather events and the record emissions make it clear that we need reliable zero carbon power, not just intermittent sources. And when nuclear is framed as part of climate solution, then the support, as I mentioned, will increase by 20 to 30 points in polls. Young people are more pragmatic. They grew up with climate change as a lived reality more than older generations like mine. So ultimately, it has to be a message of hope. Hope that we can decarbonize fast enough and that innovation can unite rather than divide us, especially innovation and technology in nuclear has the potential to help us and achieve our global climate goals. But all of that requires not only technology, we know it also requires social license. So to get global acceptance, we have to reframe as a group and bridge that and create that bridge that connects today's urgency with tomorrow's prosperity. So thank you very much for allowing me to give share some of my insights on the topic of climate change, which is very close to my heart, and very happy to answer questions.
Thank you, Mrs. Christina. Thank you for your nice presentation. So now we will open the question and answer session. Please just feel free to raise your hands or write in the chat. We don't have any question now. Okay, we have a question from Florencia. She asking, in what ways can nuclear energy be reframed to gain broader public support, especially among young and climate advocates, without downplaying concern about safety and waste?
Thank you, Florencia. As I mentioned, I believe that the industry and the experts have to be transparent and have the dialogue and explain very well the implications of nuclear waste, the implications of safety. And I believe that in the past, it's what the nuclear industry didn't do very well. They avoided the topic. But nowadays, it's quite clear from records, from data, that there hasn't been an accident in maintaining nuclear waste in local for. It hasn't been an accident in transporting nuclear waste in the last 50 years of the nuclear waste being around. So it's really important to put the facts out there and not dodge the bullet when it comes to talking about the hard topics surrounding nuclear. So it has to be frank, open, honest, but also there's a lot of misinformation around that we can debate and rebut. For example, in Australia recently, during the last election, there was an anti-nuclear campaign because some of the political parties wanted to include nuclear in the policies. And this misinformation was so large. People were talking about liquid waste being left on land, on sites, all of these things that are completely not true. And what we can't do is to avoid the conversation and set the record right. So I believe that with honesty, with data, with proper expertise and information out there, we can clear the facts and make waste a lot people more comfortable with the waste conversation.
Thank you, Christina. We don't have another question in the chat. So please, Christina, could you share with us your email address for the eventual question? Or
Yes. So in the last slide, I have my email. I'll put it on the chat box for everybody to have a look.
sorry.
I'll share my email on the chat box now.
We have other questions. So Maria is asking, in the reference of young participation is considered in activism, education, or taking place in position on the creation of politics. In your experience, what have you seen in Australia with youth and their participation in politics?
She's asking about the youth and their participation in politics in Australia?
Yeah.
Yes. So in the last election, a number of young people that turned 18 voted. And I believe that it has changed and shifted the dial in how political parties and policy has to be driven or written or focused. Because the more that we include the youth in the arguments and in the conversation, political conversation, the more we're seeing that we have to pay attention to climate change issues. We have to be open to, different new technologies and everything that has to do with what the youth is pursuing at the moment. In Australia, it's no different than in any other country where engagement is happening at much earlier age now because of social media and because of all the vehicles of easy access to information. So there's people as young as 13, 14 participating in the nuclear debate in many countries and in Australia. And that's a good thing because you want for young people to really develop, positions and understand what they expect from governments, what they expect from policy. I think that the young people, education comes through, universities and schools. So it's also important to include all of these important topics to do with energy and energy safety, energy and climate, and linking the bridge at educational programs for people who want to have access to that kind of information. So I think that young people in Australia and in many countries are now incredibly loud and incredibly knowledgeable about these things, and they didn't used to be like that in the past. So it's important to include them in every conversation and not to neglect their perceptions and values.
Okay, thank you, Christina. Adeline has a question for you. She would really appreciate the grassroots activities you recommend to approach youth and encourage them into the advocacy journey in the range of age concerns.
Sorry, is this on the chat box or?
Yeah, no, it is a question and answer, but
Okay, Sina, she would like to be able to know what activities we're running so that she can participate. Is that what she asked?
she would really appreciate the grassroots activities you recommend to approach youth and include them into the advocacy journey in the range of age concerning.
Okay, so will I be able to perhaps send her an email, or she can send me an email and I can respond to her?
Okay, I will. Thank you, Christina.
No problem.
Noreen is asking how to get public perception changes regarding nuclear energy.
That's a very complex question because it depends on who the messenger is. I believe that if the messenger in this case if the message is coming from industry, then it has to be unbiased and it's harder to believe in. But if the message is coming from governments that want to implement public policy and policy on nuclear, then it has to be, as I mentioned, inclusive. It has to be in consultation with community. It has to be honest and open and constant, because the message cannot just be one thing one day and then disappears the next day. It has to be part of the, part of a complete process of moving people from not understanding or misunderstanding nuclear to accepting nuclear. So it has to be part of a huge campaign, whether it's public, whether it's, with communities on a one-on-one basis. And it's really important to have that included in not just policymaking, but included in part of the whole public debate. So to really get the public perception to change, messaging is really important. As I mentioned, what narratives do you use? How do you approach people, whether in communities and without disregarding their views, being honest, being open, and really putting it out there, the links between climate change, emissions reduction, the good points about nuclear, without avoiding the difficult conversations as well.
All right. Okay. We don't have another question, so thank you again for your presentation and your answer.
Thanks, Tina. My pleasure.
So it's the end. We have now reached the end of today's session. I will now hand it over the organizer for the closing remark and any future announcements. Please, Florencia, you have the floor.
Thank you very much, Senna, for your great moderation, and also to Christina for the wonderful perspective she gave us for today's session. I mean, the work will never end, but we have to continue shaping different territories across the world to make nuclear a constant power of energy and increase the level of visibility that will endorse in different communities. So we really thank all the speakers, moderators, and participants for today's session. And we thank you for this thoughtful participation of today. The themes we explore, law, peace, and climate, are pillars of a responsible nuclear future. So let's carry these insights into our work and advocacy and continue to build a nuclear sector that serves both people and the planet. So tomorrow marks our final day together, and let's make it count. We have shared the WhatsApp group community if you are interested to join. Also, this will be a platform where we can stay connected during and after the school. I've shared already Christina's emails, both emails as well. So if anyone is interested to have a follow-up conversation with her, that'll be so great. And also we see Maria Jose, she's sharing an event. I think she's sharing an initiative to Adeline. Maybe that'll be a great collaboration that both of you can be placed between Cameroon and Mexico. So I would like to ask my colleague Lancina if you have any additional remarks to add for today's session, and Mrs. Eva, if she's still with us today.
Yes, I'm still here today, and wow, that was really an excellent session. I would like to thank the three speakers for making their time available to speak to all of us. And I'm sure all those of you who have listened have learned a lot today, both about nuclear law related to safety. We spoke about security yesterday and safeguards the day, I think on Monday. So you have the whole picture now about the legal framework for nuclear energy. Then the CTBTO and the CTBT and how important it is to prevent any nuclear testing, because nuclear testing sounds actually harmless. It says, oh, it's just a nuclear test, but actually it's a nuclear bomb that is detonated, and that causes exactly the same harm as what we saw in Hiroshima and Nagasaki. So we should not just downplay the importance of nuclear testing. And of course, Christina's perspective, especially not just on Australia, but on the global view of nuclear energy, was excellent. So a big thank you to the three speakers, a big thank you to Florencia and Lancina, and also to all the participants. So please get ready for the quizzes. The questions are approaching. So thank you very much. It was a pleasure to attend.
Thank you, Mrs. Eva. Over to you, Lancina, please, to close the session.
Thank you so much, Francia. Thank you so much, Eva, for your big support. I would like to thank everyone, the audience, the moderators, the speakers. When we try to go to the end of a summer school, everything is become sweet and sweet. Thank you so much for your participation. Maybe we'll be strong tomorrow for the end and to shape the future of nuclear in the world. Thank you so much.
Thank you very much. We wish you to have a very good rest of your day, depending where you are, and stay connected with us. We'll see you tomorrow. Thank you so much.
Thank you, Florencia. Bye.
Thank you, Sana. See you later. Thank you, Christina.
And thank you to the moderators. My goodness, I forgot the moderators. Thank you to
Oh.
the excellent moderation. Good job.
Don't worry, Eva.
Thank
No
you.
problem.
Welcome.